Hello learners, today we will discuss about igneous textures. Before I will discuss about the igneous textures, I will let you know about the igneous rocks. What are the igneous rocks? Igneous rocks are those rocks which are formed by cooling and consolidation of the magma. Magma is defined as a hot molten rock material which contains lot of volatiles and contains all elements which are present in the earth. So, magma, when it undergoes cooling and crystallization, it develops various types of textures. The significance of these textures is that they tell us about the story, what has happened in the past. They tell us about the process of genesis of these rocks, which is also known as petrogenesis. Two terms are very much important: fabric and texture. Fabric is non-compositional property of rock, comprises of textures and structures, whereas textures are also known as microstructures. Fabric that can be seen in the field, they are large scale features, whereas textures are microstructures which can be seen under the microscope. They cannot be seen by naked eyes. Now, what is texture? So, textures by definition, it has glass versus mineral grain proportions, their size, shapes and mutual arrangement. What you understand about the texture as a layman? Texture is the interwoven of the threads in a cloth. Similarly, in rocks there are no threads, but there are minerals. Those minerals, they are interwoven with each other. Texture based on glass versus mineral grain proportions, their sizes, shapes and mutual arrangements, they can be classified into two major categories. One is primary texture, which is produced or which is formed during crystallization of magma, and secondary textures, they are developed after the rock is consolidated or after the rock is formed. Formation and growth of crystals, it involves the processes: first initial nucleation of crystal, subsequent crystal growth, diffusion of heat. These are the three important processes which are involved during the growth of crystals in the magma. Now, igneous textures, why we study igneous texture? Igneous textures, they are studied because they tell us about crystallization path, textural equilibrium, non-explosive exsolution, fragmentation, consolidation of volcanic clast, anisotropic fabric, mafic inclusions. First, I will discuss about the fabric related to crystallization path, that is crystallinity and grain size. What is the definition of crystallinity? Crystallinity, modal percentage of mineral grains relative to glass. By definition, crystallinity means what is the modal percentage of crystallized mineral grains and relative proportion of glass, that varies from 0% to 100%. Second is the grain size, that ranges between submicroscopic, that is 0.001 millimeter size to giant sized crystals. Second is crystallinity and grain size, that depends upon rate of crystal nucleation and growth. Now, crystallinity and grain size, it is again further classified as glassy or vitrophyric texture. Another variety is called pearlitic texture or spherulitic texture. All these types of textures, they have been formed by devitrification of glass. Second is ephemeриtic or aphyric or cryptocrystalline, microcrystalline, felsitic, felty, intergranular, intersalter texture. They are all varieties of the ephemeritic textures. Third one is pheneritic texture, which is equigranular, inequigranular and seriate pegmatitic texture. These are the 5 varieties of the texture, pheneritic textures. Fourth one is porphyritic texture, which can be vitrophyric or cumulophoric. Fifth one is ophitic and picolitic. I will discuss each kind of texture in a separate manner in a detailed context. Glassy texture. Glass actually represents the melt. Glass is highly viscous liquid, disordered atomic structure formed by rapid cooling of silicate melt during crystallization. Now, obsidian. Obsidian is a variety of igneous rock which contains enormous amount of silica glass and having zero crystallinity, which is massive high silica glass having zero crystallinity. The process involved in the obsidian formation is first secondary hydration, devitrification and alteration, which also gives rise to a rock which is also known as pitch stone. Second one is devitrification process or delayed crystallization, which gives rise to felsitic or spherulitic texture. Third one is hydration and devitrification simultaneously taking place and give rise to a variety of mineral which is also known as pelagonite. I will show you all these varieties of rocks and mineral stepwise. First, obsidian and pitch stone. Obsidian showing black color, it is pitch black in color. So, we call it as pitch stone. It is a variety of obsidian showing black color, conchoidal fracture and vitreous luster, pure glass or mostly rhyolitic composition. It is alternating with light and dark flows, layers also seen in plane polarized light. This conchoidal texture can be seen in the hand specimen. Now, I will show you the pitch stone how it looks under the microscope. Pitch stone containing rod like microlights, these are all microlights, rod like microlights of plagioclase. They are mineralogically they are plagioclase in composition. It is already marked over the photomicrograph and appear as stellitic cluster. They are in the form of a cluster. They are not in the isolated rod like crystals, but they are in the cluster. Now, how a beginner can draw a section of this kind of rock under the microscope? This is a hand drawn picture of a pitch stone which shows hollow hyaline. Hollow hyaline means completely glass or hollow crystalline having fine to coarse angular crystals. This is the glass, the dotted material which is shown here is glass. It contains dots because this is all released iron, the iron released by alteration or devitrification process, and it gives turbidity in the background. And in this background you have a crystal which is also altered, it shows inclusions of iron oxide within crystals, and these inclusions are more confined to the cleavage planes. And third one is here glass giving rise to turbidity and clouding. Here the entire glass which has undergone alteration, as a result of alteration it is giving rise to turbidity. So, this is a slide of pitch stone. Another glassy rock which I am showing here is lugerite or analcite rich taschenite, that is also a glassy rock which contains few crystals. The crystals are barkivikite is a mineral, then titaniferrous agate, apatite, chlorite, plagioclase and partially altered ilmenite. These are the minerals which are oftenly found in the lugerite or analcite rich taschenite. Here I am showing the pearlitic texture. I have already discussed pearlitic texture in my classification of textures. Pearlitic texture is a fracture controlled alteration. You see the fracture here, this is the fracture, and along this fracture the alteration has taken place and it has generated a jigsaw texture over on a centimeter millimeter scale. This texture is developed on a very small scale or sometimes in a millimeter scale. Remnant accurate pearlitic crystals enclosed around fragments of microlite composed of feldspar. These are the white grayish color microlites or feldspars, they are there, but these microlites are lying or embedded within the black colored ground mass which is glass actually. Here devitrification process. What is devitrification? The glass over the time period develops crystallinity. In a glassy rock, over the time period, this is the glassy rock, over the time period it has developed some crystals, and these crystals are spherical or spherulitic in shape. Spherulites are secondary devitrification features. Spherical to ellipsoidal crystals of fibrous radiating alkali feldspar, they are all alkali feldspar crystals, and polymorph of SiO2 in a black glassy matrix. Phenocrysts are located at the center of the spherulite. Here in this center, if you see, the phenocrysts are located. I will show you phenocryst more clearly in the subsequent slide. Where in the original glass or melt, it allowed heterogeneous nucleation of crystals to occur. Spherulite range in diameter from less than 1 millimeter to 1 meter. You can imagine the size, 1 meter size, it is a huge size. Spherulitic texture occur in high silica, rhyolite and obsidian. These are the two major rock types. Rhyolite is a variety of igneous rocks, and obsidian is also variety of igneous rocks, where these two spherulitic structures are frequently seen in the field. Here, which I was discussing, the large crystal or phenocryst is developed in this center. This is spherulitic texture, and in this spherulitic texture, the central part large crystal, which is also known as phenocryst, exhibiting spherulitic texture due to devitrification of glasses. See, the entire dotted line shows the spherulite, and these spherulites, they are mostly radiating crystals. The crystals are radiating from the center, but in center you have a bigger size crystal which is not radiating, but it is equidimensional. See, another important slide of a glassy rock or pitch stone or rhyolite, it shows glassy outer rind like structure. This rind like almost irregular surface, irregular margins shown over here. Particularly in this side of this section, the irregularity is more pronounced. It is because of quenching of hot magma. Why this rind is developed? It is because of quenching. Quenching means sudden cooling of the magma, that has given rise to the rind like structure here, and consists of basaltic glass in which sparse euhedral olivine crystal is there. This is a glass, and in this glass you have olivine crystal is embedded within this glass, crystallized before extrusion. This olivine crystal was not formed at the same time when the glass was formed. It was formed prior to the crystallization of glass. That is why it has acquired a good shape, almost euhedral shape. Feathery crystals of CPX, CPX means clinopyroxene. They are feather like, feather of a bird like crystals. They are seen here. They are produced by substantial undercooling of the melt. See here how a thin section can be drawn while you are viewing this kind of rocks under the microscope. Here I am citing an example of ankaramite. Ankaramite is a variety of igneous rock which is hemicrystalline, which is due to devitrification of glass. Grain size varies from fine to coarse, euhedral phenocryst lying in a ground mass of subhedral crystal. These are all euhedral phenocryst. They are lying within the glassy ground mass, and this euhedral phenocryst also shows sign of alteration, particularly within this center, and some places it has developed a rim like structure or a corona like border, which is also known as corona structure or caliphytic borders. How this hydration and devitrification in basaltic rock looking under the microscope? I am just showing you how it looks under the microscope. In this slide, this is the case of a basalt. Basalt is also another variety of igneous rock which shows clinopyroxene. This clinopyroxene has undergone devitrification, and the process of devitrification is more on the border of the phenocryst. This is a phenocryst of clinopyroxene, and this is the border of the phenocryst which shows alteration. Because of alteration, the product which is formed is called pelagonite. Pelagonite concentrically layered in a coliform structure. You see, this is the mineral which is known as pelagonite. This pelagonite is showing concentric structure, and this concentric ring like structure is developed because of alteration of a basalt or basalt containing clinopyroxene. This clinopyroxene, the entire crystal was clinopyroxene, and this clinopyroxene has undergone alteration. Now, I will summarize the entire discussion. I have focused my discussion primarily on the variety of igneous textures. What is the definition, how the textures have been formed, and what is the classification, how they have been classified, what is the basis of their classification. All these features I have discussed, and also discussed the fine grained textures or glassy textures in detail. In my subsequent lecture, I will discuss another variety of textures.